Welcome back everyone, Patrick here. Moving on to the next question, dealing with valuations. So you are investing $4,000 into an account paying 6% interest. And based on that scenario, we got three questions here. So number one, we have to find the future value and interest earned in 3 years if the account pays either simple interest or compound interest. Find the future value and interest earned in 6 years if the account pays simple interest and compound interest. And then in number three, we're told the amount of time in part 2 is double the amount in part 1, right? 6 years versus the 3 years. How does the interest earned in both parts compare? All right, so I'm going to erase this here. Starting with number 1, we're dealing with a time period of 3 years. And so we got to do both simple interest and compound interest. So let's start with the simple interest. Now, the future value, if we're dealing with simple interest, what's the formula? It's future value equals present value times 1 plus R times T, the interest rate times the number of periods. And so if we input everything here, we would have 4,000 times 1 plus, the rate is 6%, and this is going to be for 3 years. And so doing this, we'd have 4,000, be careful with the bed mass, so we'd have 1 plus, we've got to multiply here first, so that would be 0.18. Then we'd have 4,000, 1.18. And then when we multiply these, we would end up with 4,720, right? So that's what the future value is going to be. Now, what's the interest earned going to be? Well, it's simply the difference between the future value and the principal, the present value that you invested of 4,000, like that, which is going to be $720. All right, so that's the answer for 1A. That's the future value, that's the interest earned. And this is dealing, remember, with simple interest. Now in part B, we're going to be dealing with compound interest. So 2 ways to calculate this future value, algebraically or with a financial calculator. Let me show you both. So future value, if we're doing compound interest, that's the formula. So we're taking 4,000, investing it at 6% for 3 years. So this would be 4,000, 1.06 to the power of 3. You do this portion first, then multiply it by 4,000, and you'd end up with 4,764. A slightly larger value than this, and that makes sense because with compound interest, you're making interest on interest. You're not just making that simple interest every year. So it makes sense that this amount is going to be greater than that amount. And then the interest earned, same thing. It's going to be the future value minus the present value, 4,764 minus 4,000, which would give us 764. And even though the question doesn't ask this interest earned, the compound interest earned, is broken down into 2 parts, right? It's the simple interest portion, which is just the 720, right? That's the $240 you're making every year. 6% of 4,000 is 240. You're making that every year. But then there's also the interest on interest portion. The interest you're making on the interest, and that would be the difference between these, which would be $44. Right? They didn't ask for this here in the question, but thought I would mention it anyway. Right? But with what they're asking, the interest earned is 764, slightly higher than 720, and the future value is 4,764. Now we can also get this future value amount with the financial calculator, and so the way you would do that is you would plug in 4,000, you're investing that, so negative cash flow, the interest rate is 6%, for 3 years, there's no payments in between. And so when you solve for that future value, you would end up getting that amount right there. And then again, to get this amount, you just take the difference between the future value and that present value. Right? So these amounts here, simple interest, compound interest, and this was for a time period of 3 years. Now let's see what happens when we up this. So everything else is going to stay constant. The interest rate, the present value amount. It's just now we're going to do it for 6 years. We're going to double the time. So 2A, the future value, pretend that the account pays simple interest. So we'll have 1 plus RT here, 4,000, 1 plus 0.06, but now it's going to be for 6 years. So this would end up being 4,000, 1 plus 0.36, 4,000, 1.36. When you multiply these two, you'd end up with 5,440. That's what the future value is going to be if the account is paying simple interest. Right? Another way is 6% of 4,000 is 240. Multiply that by 6 and you would get 1,440. You add that to the principal, and that's actually going to be the interest earned. Right? The interest earned is just going to be the future value minus the present value, which would give us that right there. Right? So those are the two answers for 2A. So everything's staying the same. The only thing that's changing is that 6 years. So the future value was 5,440, and then the interest was 1,440. Now what's going to happen if it's going to be compound interest for 6 years? Well, to find the future value, 2 ways to do it. Algebraically, right? So this would be 4,000 times 1.06 to the power of 6. And when you do that calculation, making sure you do the exponent first and then multiplying by the 4,000, you'd end up with 5,674. That's what the future value is going to be if the account is paying compound interest. And to get that with the financial calculator, you can also put the PV as 4,000, negative 4,000, since you're investing that. 6%, 6 years, no payments in between, and then solve for future value. You should get that amount right there. So that's the future value. What's the interest earned going to be? Just the difference between that and the present value, the amount you invested. Right? The amount you get minus the amount you invest gives you the interest that you've earned. And so that would end up being $1,674. Right, so those are the respective amounts. Both of this is simple. This is for 6 years, this is for 3 years, and then this is compound for 3 years. This is compound for 6 years. Now, what they're asking in part 3, they're saying that this was double the amount of time that this was. And what they want you to do now is compare the interest earned between these two time periods. And notice that when we compare the two simple interest accounts, the difference in the interest earned is proportional to the time. So the time was doubled from 3 years to 6 years. notice that the interest earned was also doubled, right? If we multiply this by 2, we would end up with this. But notice that here, that relation doesn't hold. Here, the interest we made was $764, and then this here was $1,674, more than double this. And so that's the point I wanted to make with this video, is that with simple interest, interest earned is directly proportional to the amount of time. So if you hold all variables constant and you just change the amount of time, if you double it, if you triple it, quadruple it, half it, whatever you're doing, that's going to have that same effect on the interest earned. The interest is going to double if you double the time, or it's going to triple if you triple the time. Or if you half the time, then the interest is going to get halved with simple interest. But this here, this direct proportion, doesn't hold with compound interest, because it's compounding, right? It's like this is linear and the compound interest is exponential. And so the changes are getting bigger and bigger as time goes on each time, right? So it's not directly proportional. Notice the time got doubled, but the interest was more than doubled versus here. It wasn't directly proportional. All right, so that's the point I wanted to make with this video, comparing simple interest to compound interest.